Okay, for the 6.2 notes, we're going to look at congruent triangles once more, but we're going to look at some postulates, some rules that tell us whether or not two triangles are congruent based on limited information. So the first postulate we're going to take a look at is called the SSS, or side-side-side postulate. And what it means is if all three sides of two triangles are congruent, then those two triangles are congruent. So, for example, if I knew that triangle ABC here, triangle DEF, if I knew that all of their sides were congruent, like this, then I know that those triangles are congruent. It essentially locks those shapes in place, and I can't have any other triangle that has those three sides. It will always be congruent. So I can write my statement, triangle ABC is congruent to triangle DEF. So use the SSS postulate to determine whether the triangles are congruent. I'm just going to say yes or no. So for example A, I have one pair of congruent sides. I have two pairs of congruent sides. And because they share this third side, I know that that side is congruent to itself. So yes, but based on the side-side-side postulate, these triangles are congruent. Now for example B, I do have one pair of sides that are both 8 inches. Those are congruent. I have one shared side that is congruent, but I have no information about that third side. So two sides being the same is not enough to determine congruency, because this third side could be different. So not enough information. I cannot determine that those two triangles are congruent. Okay, the next postulate is called SAS, or side angle side. You have two sides and the included angle, that's the angle between those two sides. If two triangles are congruent, then the triangles are congruent. So again, if I have my triangles ABC and triangles DEF here, if I know that two sides, so let's say side AB and side DE and side AC and side DF, if I know those two sides are congruent, and I also know that the angle between them is congruent, then that is enough information to make sure that these two triangles are congruent. And that's because this angle sort of locks these two sides in place, meaning this third side has no choice but to be the same. So I know here that triangle ABC is congruent to triangle DEF. So let's use this postulate to determine whether these triangles are congruent. Side, angle, side. Remember, it's two sides and the included angle. So here in example A, I do have two sides and one angle, but it's not the included angle. And so that means that I could change this angle however I wanted, and it could result in different shaped triangles. So this is not enough information. However, example B does. I have side, I have the angle, I have the side. Included angle, side, side. That's why it's in between here. Side, angle, side. It's the included angle. So yes, these are congruent. Okay, our next postulate is the angle, side, angle postulate. If two angles and the included side of two triangles are congruent, then the triangles are congruent. It's kind of the same idea. The two angles, let's say I have my triangles ABC, DEF. They both have a 90-degree angle, and let's say that this angle is the same with this included side. Those two angles and that side lock that triangle into place, and these two sides have no choice but to meet right here. There is no other triangle that those could be, because I can't wiggle those angles around at all. Can't change it. There's no other triangle that could be if I have that information. So again, I know that triangle ABC is congruent to triangle DEF here. Same idea. We're going to use that angle, side angle postulate to determine whether the triangles are congruent. So again, two angles and the included side. So this first example here, I do have two angles. I have these top angles and these 90-degree angles. And I also do have the side between them because they share that side, which means it is congruent to itself. So yes, I do know that these two triangles are congruent. On example B, I have angle, and they share this side. So I do have a side, but it's not the included side. So I can't use the angle side angle postulate because that side is not included in between those two angles. So I do not have enough information there. Okay, let's keep going. Angle side angle postulate. Now this might seem unfair based on what I just said on example B, but again, I had to use the angle side angle postulate for that one. So not based on the angle side angle. But if I was using the angle angle side, if two angles and a non-included side of the two triangles are congruent, then the triangles are congruent. So this one up here, I could have used that angle angle side postulate. So again, I've got my triangles. We'll call them ABC and D, E, F. So if I have two angles, let's say I have angle A and angle D and angle B and angle E and a non-included side. So any side here. So let's say this side, AC and DF. If those are congruent, if I have that information, then the triangles are also congruent. Because again, there is no other way to have that triangle in those pieces without being the same triangle. I can't make some third triangle that has that information but is a different shape. So triangle ABC is congruent to triangle DEF. So again, the angle angle side postulate, we're going to use that to determine whether these triangles are congruent. So two angles and a non-included side. So here it looks like I have two angles and they share this side right here. That's a non-included side. It's not between the two angles. So yes, these are congruent. And over here, I have all three angles congruent, but I have no information about the sides. So I can't say that those are congruent. I don't have enough information to say that those triangles are congruent. So that is unfortunately a no. Three angles is not enough information to determine if two triangles are congruent. Okay, the last one here is called the hypotenuse leg postulate. If the hypotenuse, that's in a right triangle specifically, that's the side across from the right angle. So if the hypotenuse and one leg of two right triangles are congruent, then the triangles are congruent. So this one uses the fact that in a right triangle, one of the angles is always 90. So we always know we have an angle. And so if the hypotenuse and one leg are congruent, then the triangles are congruent. So hypotenuse leg, we have the 90-degree angle. We have two sides, one of them being the hypotenuse. Then these two triangles are congruent. And again, that uses the fact that one of these angles is 90 degrees. And so again, that kind of locks in the other angles as well with those two sides. Having these one angle and two sides only works if that is a right angle. It doesn't work otherwise. So using this hypotenuse leg postulate to determine whether the triangles are congruent, we have to have the hypotenuse. So on example A, that is this side, it is shared, so it is congruent. We have the hypotenuse. We have another leg right here, and we have a 90-degree angle. So yes, this is enough information. On example B, we do have two sides, We have a 10-foot side and a 4-foot side, but there is no information about this angle. I don't know if it's a 90-degree angle or not. It kind of looks like one, but I can't assume that it is. So this is not enough information to determine. Okay, so those are 5 postulates you can use to determine if two triangles are congruent. Now, if you have all the information, if you have all 3 sides and all 3 angles, obviously those triangles are congruent. But with limited information, we can use these postulates to determine congruency without having all the information for those triangles.